Yeah, Yiping. So what's the philosophy behind taking so much behavior over into the node? Because traditionally, when we get into nodes and then walkers they they seem to model behavior. They seem to be designed to model behavior, whereas
Mhm.
nodes are more structural. So
Yeah, I think so. I'll give my answer, and then I think Jason will probably be able to do a better explanation. I think the main benefit I see now that I've done it actually is it made things really modular. In that, you can, in that your program and the successful execution of your logic doesn't depend on a specific graph architecture and construction. So you're able to move node from place to places and they kind of connect them differently with different edges, and your program will still work, right? It makes it really easy to re-architect your conversational architecture. So the example that I was giving, right? So we have this HLP capability that it's like a study buddy kind of capability that are right now is only triggered after you're already in a competency, after you're already in a specific capability, right? You can't access a root right now. But one of the improvements we want to do is actually hoist that up so that you can always ask it with a specific intent. Really, in practice, all we need to do, since all the abilities are in the node, is we just delete that edge and then create a new edge. And that's all you need to do. And because when you're moving the node definition, you're also moving all the logic with it. As opposed to if that logic's in the walker, I would imagine it's gonna be a lot more involved to change that, because like it's yeah, because you're gonna have to like yeah, you didn't have to like worry I'm just thinking like you didn't have to like change like I don't know multiple if statement in different like in different hierarchical level, and it's you don't have that guarantee of it will work because the node abilities are all the logic is encapsulated with the node. As long as the node stays like untouched and kosher, like you have the guarantee that it will work. But if it's part of your water logic, you don't have that guarantee, right? Because you're essentially changing a sequential logic, and anything.
Right.
Yeah, and just to dovetail, yeah, just to dovetail on that one. It's really it really is inspired by various object-oriented concepts, right? And so you imagine the node has a semantic, like it has a certain semantic as to what it represents and what it does, right? And so when a walker arrives, you might want the behavior of the program to be centric to where that walker is in the data, right? So if you're on node type A, then there's a certain set of behaviors that's different than node type B. When you do it all in the walkers, your walker has to specify the entire breadth of behaviors as you scale the different types of nodes you have. And so you can imagine your walker gets bigger and bigger and more complicated because now the walker needs to know everything it's supposed to do on every kind of node, right? So this allows you to take the compute and fuse it with the kind of data that the walker happens to be on. And those node abilities have the ability to inject knowledge into the walker's mind or data, and it can also direct the walker. Like you can tell the walker to now go here or now go there, right? So basically the behavior that's associated with the nodes can stay with it, and that helps you to build more scalable code, right? Because you can keep adding new node types, you can change the semantics of a node and just introduce it into your graph, and then the behavior of the walker, you don't have to touch anything else. So you get this modularity and encapsulation of how you implement the algorithmic semantics of different kinds of data types. And so the way I think about it is you're fusing compute in the data, right? And so it helps with this kind of data spatial modularity. Another one of the key philosophical goals of Jac is that you could nimbly add new behaviors without having to re-architect everything, right? This is one of the biggest problems I've seen like at Clink and in other big projects, right? You build it one way, it becomes monolithic. And when you want to change one thing, all of a sudden you have to go rip everything apart and rebuild all this new infrastructure to support that one thing. But with the ability to just add new walkers to an ecosystem of existing walkers and nodes, and the ability to add new nodes to an existing ecosystem, you can actually test out new ideas without having to touch too much of your code. So that's one of the goals. And this is a feature that allows you to do that by siloing behavior, not just in walkers, but also siloing behavior in the data types themselves, the nodes themselves. So it helps with scalable and nimble coding.
Get it, I get it. And are there any, well, there's obviously a protocol that's defined in terms of what the walker should execute based on the behaviors of the particular node.
Mm-hmm.
So as you build out and extend, you just have to update that protocol in the walker and then
yeah, and then the walker, exactly. And the thing is, as a programmer, you get to decide, right? So you get to decide what compute makes sense for you, for the walker to do, and what makes sense to happen fused with the data. It's a very intuitive thing, but when you code in this style, it makes a lot of intuitive sense, right? This is one of the things where I was pushing Yiping and he was like, oh, I'm so comfortable doing it the old way, 1.0 way, like 1.2 way or whatever. I'm so comfortable just putting it in, like, why do you keep pushing me to do it in this walker? And then when he started pushing his compute there, he was just like, holy shit, this is so much more fun now. Like, I totally get it. So, it's one of those things where when you try it, it like starts to really make this intuitive sense. Yeah.
Cool. Yeah, that makes sense.
Yeah.
Okay.
Cool. Any other questions from the team?
Not a question. I think it's a big change from how we've done it in the earlier versions, right? So I'm like looking at that and thinking I probably have to think of rewriting the whole CSV.
Well, I'm doing that for Mitra right now. Actually, I'm rewriting all of Mitra, so I feel you.
Yeah, but it's very interesting, and in terms of like obviously, if I were to start from scratch with CSV, I'll do it very differently. Like having seen what is possible now, right? So it's exciting.
That's super cool, man. And and you could also iteratively kind of move little bit by little bit, maybe. I know a rewrite sounds daunting, but here's the good news, guys. Like at this point, we have essentially a full language, right? So the way things change in the future is going to be more minimal, right? Because we have some of the key concepts. We have polymorphism. We have something that's kind of like methods and overloading. We've got a lot of the key DNA of the language defined. So I think we don't worry too much. It's not going to change as much into the future. But yeah, man, that's cool.
So Jason, I take it you're gonna prioritize this light walker heavy node philosophy of development.
Yeah, it seems to make I think it seems to make a lot of sense when you have large problems you want to solve and you want to retain that kind of modularity and kind of scalability, encapsulation in your code. So I think that's a good default practice. But of course, coders are free to do, like even in object-oriented programming languages, right? Like you don't always use classes when you're hacking Python. Like you don't always use classes. You don't need classes many of the times. And so, like JSCTL's code base has no classes in Jaseci, but like everything else is very object-oriented in Jaseci because JSCTL doesn't really need classes. And so I think there's going to be depending on the need, you can choose like, it's the node blocks, the node code blocks. It solves your problem if your problem isn't too large scale. You just kind of put a little. I want the walker to behave like this on that node type, and I want the walker to behave like this on this other node type. Totally fine. Like that's perfect for some problems, and then in other problems you might want to really have a very data spatial implementation. So
Would you say that this shift is arbitrary? Does it impact performance in any way, given the fact that the nodes are thicker?
No, actually, from a compute standpoint, it doesn't have a performance impact. There is a whole roadmap of optimizations that I can't wait to get started. I'm hoping, folks like Shyam could actually help with just making things faster, more efficient. But when choosing between these two, there's no performance concern because it's just different code executing as opposed to code inside the walker itself. The thing is, some of this we got to empirically test too, right? So I should run an experiment to see. You loop a billion times, like which one's faster or slower. Yeah.
And that was my question as well, because I have, like, at least in my case, there are like nodes which are like 200 nodes of a particular type which we have to loop through. Is that gonna make it like super slow?
Well, in the infrastructure now, as soon as you touch a node, you're experiencing the slowness, right? Whether or not you execute based on that node, the slowness comes from the lookup of the node. And there's a lot to talk about there, Asim, because one thing we've discovered is, and it makes total sense. When you delete the Redis cache and you let it come back, sometimes things get crazy faster. Basically, our Redis caching layer is implemented in the most naive way imaginable. This is also another thing I think, Shyam is going to be instrumental on. Eventually, I'd love for him to look at our implementation of our Redis cache and make sure we have a good policy. I think what's happening is once your cache fills up, like every request then thrashes to DB, and that's where a lot of the slowness comes out. So there's some internal stuff. I mean, there's so much low-hanging fruit, dude, like to optimize and make this thing fast. We're going to start to engage that journey now that we have the functionality piece solved. So things are going to get crazy fast, but most of the slowness that you guys experience comes from having to load those nodes from a DB. And the Redis solves that, but our Redis is implemented stupidly right now, like very stupidly. So we're going to improve that.
Yeah, last question. Any thoughts, given the fact that there's a protocol involved, any thoughts about the equivalent of an interface? So that once you define those operations and those abilities on their node, the walker's kind of like, it's a cleaner type of the walker. What do you think?
Yeah, no, that totally makes sense. And you mean an interface as in like Java?
It'll start to be like an adapted version of it, given the fact that once you define the abilities on a node, if I'm understanding it correctly, the walker needs to sequence them in a particular way to operate on a node. So if there is some way in which you can define that and then just have the walker just
that's actually on the roadmap, dude. And it's basically there's a couple things related to that on the roadmap. It's the ability to schedule paths through a graph. So you can schedule a path for a walker to traverse. And then there's gonna be capabilities like you can actually just point to a node and say, find shortest path. And then there's a lot with walker scheduling paths and also being able to get the history of the paths that a walker has walked. So a lot of those kinds of capabilities is gonna be relevant there and is actually absolutely on the roadmap.
Awesome.
And it's going to be super powerful and novel, right? Like this is novel shit, you know what I'm saying? Which is exciting from a research standpoint. Sorry. Yeah.
Cool.
Yeah.
Yeah, good stuff, guys. Yeah.
Cool. Awesome. Excellent stuff, Yiping, dude. And this is just the beginning, right? This is like 1,000-foot view. We're on a journey of creating the documentation and the educational materials all the way through up and down the language. So we're starting that journey. It's tough. It takes time. It takes patience, but more to come. Eldon's going to be a bit of a dojo master. I call him the dojo master, right? Because he's working with the documentation person right now on that team. And he's creating a roadmap for how we educate the world and upskill the world on this stuff. So more to come there. And there's so much more to talk about with the architecture of Jaseci too. So I might do one or two of these too. It's going to be cool. Yeah, man. Awesome. Well, thank you all for spending the time. And just the beginning, if it went over a lot of your guys' heads, that's okay. That's supposed to be that way because that's why we recorded the video. And just keep tinkering.
Yeah.
Awesome.
So thanks a lot, Yiping, for this. So it actually helped me a lot on my personal basis because the roadmap that I was taking for my chatbot, I was thinking similar to this. Now with your explanation, the logic how to build that is very clear. So
Nice.
thanks
Nice.
for this.
That makes
Yeah.
me happy.
Hell yeah. Hell yeah.
Yeah.
What? Huge. Awesome.
Yeah.
Oh,
Actually,
man.
thanks. Yeah.
Awesome. Thanks.
Awesome.
Thanks so much, everybody.
Talk to you guys.
Thanks.
Yeah. Talk soon. Yep.